morning, everyone, and welcome to today's very different HSMA session, our first ever HSMA Hackathon, in which you are going to be working in your groups, trying to use some of your new skills to tackle a problem of your choosing, and come out the other side with some interesting insights. So this is the first time we've ever done anything like this on HSMA. We're hoping this is a good idea. We shall see by the end of the day. But we're also thinking this could be a really nice way of getting you to practice some of your recent skills. So this is particularly focusing on your new natural language processing skills today, although you'll likely draw in aspects from the rest of the course as well. But also really good practice for essentially what you're going to be doing in a couple months' time as you start to go off and use your new skills on your own projects, on things that are important for your organizations, and apply these new skills and sort of go out into the wild with armed with your new tool set. So hopefully this is kind of a little a sort of miniature version of some of the things that you might want to consider and think about as you're doing those projects, all condensed into a single day. If this goes well, I think Sammy and I were talking about potentially for the next round of HSMA, even turning this into the revision sessions, so having one of these for each module essentially, and allowing you then to practice your skills from that module. So it'd be interesting to get your feedback on how you think that would work, and how you felt today went as well. So most of today is going to be you hands-on in your groups doing some stuff. So I've got a little bit of an introduction just to outline how it's all going to work first. So as I say, this is going to be a very different kind of session, a hackathon session. You're going to be working in your groups all day, basically. And you're going to be using your new natural language processing skills. So a couple of weeks ago, we covered things like word clouds, vectorizations, using bag of words. We looked at cosine similarity to look at similarity of documents. Then last week, we looked at extracting named entity information from free text. We looked at text classification, in which we classify text into different categories. Specifically, we looked at sentiment analysis, but obviously the same principle applies. If you're not classifying by sentiment, but by something else, exactly the same principles apply. And you're going to be using those new skills and possibly others as well. So don't feel constrained today by just the stuff you've learned. If your group feels that you want to go off and try something that we have not covered, but you'd like to try something out, you found a little tutorial, somebody knows a little bit about something, if you're all happy with that as a group, then by all means go and do that. There's plenty of flexibility for you to do that, but just make sure that your group is happy to do that. But primarily, most of you are likely going to be using the skills that we've covered. And you're going to be using this on some real-world data, real data sets, to answer some research questions that you decide and discover, hopefully, some interesting insights. Now, at the end of the day, at 3:30 specifically, each group is going to be asked to present their projects, what they've done today, what they found in their projects, and we're hoping to have a couple members of the wider Pencal team who are going to drop in to listen in on that as well. So nice practice for you delivering presentations as part of your real-world projects too. We're going to be awarding a lot of PSG points. You'll see there's 465 PSG points that will be distributed out today. So the leaderboards, whatever they look like now, are going to look very different by the end of today. Literally anything could happen as a result of this. And we're going to be awarding points for all sorts of different categories, and I'll explain a bit more about that in a moment. So there's basically three parts to the day. Part one, which you're going to be starting in a moment, is the project design part. So you're basically going to have an hour in order to do that, where you'll work in your groups. You're basically going to come together and have a look at different data sets, and you're going to look at, decide which one you're going to use, You're going to decide what your research question or questions are going to be, what approaches you're going to take. You basically come up with a little mini sort of project plan, what you intend to do. You'll then give a short 2-minute presentation after the hour to the group on basically what your project design is going to be, and Sammy and I will confer and award some PSG points for the best 5 proposals. Then part 2, which is the bulk of the day, will basically take you up all the way till 3:30, and this is where you are going to basically enact your plans, and you're going to develop your code and build your models and do all that kind of stuff. You can, as I say, you can choose any of the NLP methods that we've covered. You can also choose another approach if your group is happy with that. I should also add the disclaimer: it has to be FOSS. You can't go off using proprietary stuff. It has to be FOSS. This is HSMA. We have limits. And once the code's developed, then you will then use your code to answer your questions, generate insights. You may find that in doing that, it will generate more questions, and then you may go off and explore other things too. And then the final part is that final hour of the day from 3:30 to 4:30, the project dissemination hour, where you will give a 5-minute presentation of your project, talk about what you found, and there will be a lot. This is where most of the PSG points are going to come in, where we will be awarding PSG points for various categories of excellence. So just to go over these in a bit more detail. Part 1, as I say, you're going to split into groups. You'll have an hour. Here are the things you're basically going to need to do within that hour, this first hour. You're going to explore some public data sets, publicly available data that you can use to try and do some natural language processing work. I'll talk a bit more about that in a moment. You'll then decide on the data set you're going to use and what your questions are going to be. Remember our advice from right back at the start of the course: keep those questions clear and focused. Basically, what are you going to use this data to try and find out? What are the questions you're going to try and answer? And then decide on which approaches you're going to take. So, you're going to do some text classification. You can use some neural networks to do that. You're going to generate some word clouds, whatever you're going to do. How are you going to pre-process your data? This data that we're sending you out to look at, you're probably going to need some pre-processing. You're going out in the wild and grabbing some data, so you probably have to do stuff with it first. So have a look think about what you're going to do there. Think about what outputs you'll generate, what your deliverables will be. Are you going to just generate an answer to the question? Are you going to create a little piece of code that people can run and feed in their own data? What are you going to do as part of that? Try and work up a kind of plan of action for how you're going to tackle the project in the bulk of the day, what steps you're going to do, who's going to undertake them. Those plans may well change over the course of the day. That's okay. Part of being modelers and data scientists is being flexible. You may even find that the data set you pick, it's not working for what you want, and actually you might decide to change tack entirely. That's okay. So be flexible with that kind of thing. Hopefully, I'll come back to that in a moment. And then just before you come back after that first hour, you'll need to put together no more than, I'd recommend a single slide, to be honest, but certainly no more than 2 slides. Very brief 2-minute presentation, just a quick pitch that you're going to give, which will outline: this is the data that we found that we're going to use. These are the questions that we're going to answer, and this is how we're planning to do it. And that's basically what you're going to pitch. And as I say, you'll have the 2-minute presentation. Sammy and I will then award some preliminary points for what we think are the best 5 proposals for that. So there are lots of publicly available data sets that are really good for natural language processing. Kaggle is an obvious choice, and so I've linked to Kaggle's data sets here. Kaggle's got loads and loads of stuff on machine learning that's good for machine learning, and it's got lots of stuff that is good for natural language processing specifically. And you can search by various terms in the Kaggle data sets. And also by using the tags, so the filter button. If you click the filter button on the right, you can look at various tags. NLP is a good tag that will bring up a lot of natural language processing type data. So obviously you're after kind of text-based data or data that contains some text data. You can use whatever data set you like. It's entirely up to you. You should note that different data sets will have different file types. Now, quite a few will have use CSV or text files for their NLP data. They will obviously be the easiest for you to work with, given based on your existing skills, because that's how we've taught you over the last couple of weeks how to manipulate those kind of things. There will also be you'll see JSON files in there in some of the ones I was looking at. If you are comfortable to do that and to extract the data, please do that. But I'll just flag that up, that just make sure that you're comfortable with the file type, to make sure that you'd be happy extracting the data from that and pulling the data, etc. So I've got some example data. These are just ones I randomly picked out as I was looking through that looked all right and looked as though they might be okay. Feel free to have a look at these or completely ignore them. As I say, it's entirely up to you. I also cannot vouch for, beyond an initial glance and a little sort of explore, and they looked, pretty good for this kind of thing. They might turn out to be rubbish, so I don't know. But these are ones that kind of jumped out to me, that looked okay on an initial search. But I do not feel constrained by just looking at these, and do have a look at what else is out there. It's really important you have a look and explore this kind of stuff for yourself. Also be aware that there are very different file sizes for different sizes of data sets. So this one that's got 200,000 medical research paper abstracts. It's nearly a gigabyte in size, so be aware of that. Whereas some of them are much smaller, like this Supreme Court judgment prediction data set here, which is 4.37 megabytes. The other thing to flag up, these ones that I've kind of identified here, they're all either CSV or text files, so you would be safe on those. So once you've presented your project plans after that first part, as I say, you're going to spend the most of the day actually working on your projects, developing up your code, testing it, applying it to try and answer your questions, etc., etc. As I say, you might find that in doing that, it generates more questions and you go off exploring in different directions, possibly even directions you hadn't anticipated at the start. That's all part of your journey as a data scientist exploring this data. You must remember, though, as part of this, it'll be very easy to get lost in all this, that you will also need to put together a 5-minute presentation before 3:30 that will basically describe your project, what you've done today, what you set out to do, what you did, what you found, and what insights you've drawn. You should also decide who's going to present on behalf of your group, and you'll basically have until 3:30 to work on your projects and to get those presentations written. So there will be no kind of formal breaks or anything like that. Obviously, I encourage you to take breaks and to take a break at lunch and stuff like that, but we will basically just, once we get to part 2, breakout rooms will open, we'll be floating around, and then it's up to you what you do. You're over till 3:30. Now, I'd strongly encourage, hopefully you've seen the note we posted on Slack. I'd strongly encourage you, if you haven't already, to check out the live share extension in VS Code. If your group can get it working, obviously some of you may have IT restrictions. Sammy and I checked it out yesterday. And actually, it's pretty straightforward to use. I know the Zilog group have been using it quite extensively, and I think a few others. It's a really easy way if you're all using VS Code. I know that's not always the case in your groups, but if you're all using VS Code, you can all dial in and work on the same piece of code at the same time. However you decide, you don't have to do that. However you decide to do it, can I ask that each group has somebody screen sharing, because Sammy and I are going to be floating around all day. And we're going to want to see what you're doing and hearing the conversations that you're having. So however you decide to collaborate, make sure that you've got screen sharing and conversation going on, because some of the points that we'll be awarding will be based on things we hear throughout the day as well. Then in part 3, as I say, you'll be asked to deliver 5-minute presentations. I will be strict with time because obviously we've got 10 groups to get through. I should also flag up as well at this stage that we have got the RJ Macau group open. The RJ Macau group obviously won't get any PSG points, but if you would like to use today not to gain PSG points, but you want to take things a little bit more slowly, but still work on a project like this, the group is available for you. That space is available for you there. We won't be mandating that you have to, in that group, that you have to present at the end of the day. However, if you would like to, you are very, very welcome to do so. And you can make that decision later based on sort of how you get on throughout the day. So please bear that in mind. So for your presentations, as it'll be 5 minutes. Questions we'll take in the chat, so you don't have to stop for questions, and we encourage people to chat in the Zoom chat to ask questions and talk about the presentations they're hearing. And there's going to be lots and lots of PSG points available. There will basically be 2 streams of awards. There will be the judging panel, which is myself and Sammy, which will award excellence in various categories. And there will also be a people's vote for the best projects. I'll come back to that in a moment. So the awards that we are going to give for projects, most awards are going to be awarding for both first and second place, with first place getting 25 points, second place getting 15 points. In these various categories. So excellence in application of NLP and technical skills. So basically that's an award for the top 2 projects that we think have demonstrated really good use of the kind of technical skills that we've shown you over the last couple of weeks and beyond. So if you come up with really good technical solutions, really good application of the NLP skills that we've shown you, that kind of thing. Excellence in dissemination is basically the quality of your presentation, so how well you're able to share and talk about and present the information about your projects. Excellence in insight generation, result interpretation, and impact. This is basically how well did you answer the so what question. Yes, you may have found this. You've created a lovely word cloud. You've created this model that correctly, accurately identifies the correct classification of text 85% of the time. Great, but so what? So always think about that kind of so what question. What does this mean? What are the results telling you? How might you interpret that? What are the implications of that, and what might the impact be? So the 2 teams that we think demonstrate that the best will get some points for that. Excellence in teamwork and collaboration, really important skill to have. And we will be, Sammy and I will be judging that mainly as we float around over the course of the day, listening into the conversations that you're having, how you're working together, how you're splitting up tasks, how you're coming together, sharing ideas, all that kind of thing we'll be looking at for this award. Excellence in creativity, design, and problem solving. Basically, are you thinking outside the box? Have you, not just thought, okay, let's just do something that looks like we did last week. Let's think a little bit more creatively. Actually, should we try doing this and then mixing it with that? And should we try this approach here? So creativity in problem solving is such an important skill for modeling and data science. So can you demonstrate that you've thought outside the box a little bit in terms of how you're approaching this kind of stuff? And then there'll be 2 larger awards. One for the best overall project. So the award winner for the day, what we think is the best overall project of the day, will get a massive 60 points. And then the honourable mention, the one that came in close to that best overall project, will get a 30 points as well. And that's in addition to the points here. And also in addition to the people's vote, because yes, today you get a say in how points get allocated as well. So as well as the points that we will be allocating, every HSMA here will be able to vote for their favourite projects. You will have basically 100 points that you can allocate across the teams. You can't allocate points to your own team. We will be posting a link to a Menti survey at the start of the presentation session at 3:30 that will allow you to do this. and you can allocate points as you watch the presentations, but we ask you to avoid submitting your final scores until all teams have presented, so that you've made a fair judgment and everybody has presented. And then basically what we're going to do, once all the results are in, the teams will be awarded PSG points based on the overall percentage split for the People's Vote Awards. So, for example, if the team in second place got 34% of everybody's point allocation, they will get 34 PSG points. Okay, so hopefully that's all clear. We're also, at the end of the day as well, going to ask each team to share their code. You should drag and drop your Pi files into your PSG channel into Slack. Don't copy it in as a message that'll disrupt the formatting or a code block. Actually drag and drop the files themselves, or file, or whatever it may be you'll have. We will then upload this stuff to the GitHub repository for this session. When we get to the Git training in module 7, you'll be able to do this yourself. But for now, we will do this for you. Okay, that was a lot of information. Sammy, are there any questions about any of that?
So the only one that's come through is whether it's okay to use our own data sets. So from that, I'd say own data sets in terms of data sets that we haven't put in the slides, absolutely fine. You know, anything that's sort of freely available on the internet. In terms of own data sets from your organizations, probably not, unless there is something that you do have freely shareable, but would be very mindful of any data sharing concerns around that. So.
Yeah, absolutely. So yeah, there's nothing strictly stopping you from using a data set from your organization, except your organization may well have something to say about it, because not only will you be sharing this, you'll have to share this with others today, it'll also be being shared in the presentation and will be broadcast on YouTube. So be aware of that, which is why we've kind of steered you towards publicly available data sets. If you've got permission to, I mean, I know some organizations have publicly available data. That's fine. So yes, you are allowed to use stuff like that, but just be aware of any information sharing requirements that you need to do. Anything on Kaggle, obviously, you can, or anything anywhere else that is publicly available, you are entitled to use. Was that the only question, Sammy?
Yeah, only question. Only other thing I'll highlight is that UN has shared in the chat some open source friends and family test data. So if anyone is interested in doing that, then that is available as well.
Fantastic. That sounds fantastic. Thank you very much. Okay, so in which case, I've gone completely over there, but that's okay. We've got plenty of time today. So part 1, this is what you're going to do first of all. So I'm going to send you off now for an hour. So we'll resume at 5 to 11, and you'll get, each group will give a 2-minute presentation, a 2-minute pitch on what their plan is going to be, what data set you're going to use, what questions you're going to try and answer, what approaches you're going to take, all that kind of stuff. So you've now got 1 hour. As I say, there will be no formal breaks built in, so make sure you take breaks as and when you need to take them. But otherwise, we look forward to seeing you in an hour. Sammy and I will be now floating around the rooms and listening in. Please ignore us unless you need any help. And I can't wait to see you in an hour and see what ideas you come up with. So let me stop sharing and let's open up the breakout rooms. Hi everyone, welcome back. So, went around all the rooms, heard some really interesting conversations going on. So really, I'm really looking forward to how this is going to develop over the day. Some really interesting ideas that we were hearing. So fantastic to hear you all exploring this kind of stuff. So I'm going to ask you each group is going to give a 2-minute pitch. I'm going to be strict with time. I'm going to put up the timer. Because we need to get through quite a few, so you'll have just 2 minutes to talk about what your ideas, what data set you're going to be using, what your research questions are going to be, and how you are planning to do it. Sammy and I will then confer. We'll probably do that. So once the presentations are complete, we'll put you into your breakout rooms again to actually work on your projects, and then we'll announce it on Slack, the top 5 project ideas as judged by us. So we'll just for simplicity go through in order. So let's start with Agnes.
Hi, I'm just gonna present my screen. Uh, do let me know if you can see the slide.
Yeah, that's come through okay.
All right, you're gonna start a timer just so
Got the
I.
timer? Yeah, there you go.
All right, cool. Right, so we scanned through the Kaggle data sets and decided that we want to do classification using mental health subreddits. Um, So we're going to be using two data sets. One of them is a data set where it's 50% depression subreddit and 50% other subreddits to train our model. Then we're going to test that on a data set that contains subreddits from for multiple mental health conditions. So we want to address if you can identify whether a post comes from the depression subreddit. And the second part is, can you still make that identification in the context of other mental health conditions being present? So the approach is obviously first developing our model using the initial data set. And then the second part of that is testing it on unseen data with containing generic sort of mental health problems. So our first method is to create a word cloud, bit of exploratory analysis just to see understand better the data we're working with. Then obviously some vectorization to get it into the format that we need for our machine learning, a neural network for the classification, and then we need to compile the model so that we can apply it to the unseen data. Pre-processing, we've put not applicable for now because it comes from Kaggle, it's already sort of processed. The initial outputs will be a column on the second data set to compare the mental health condition of the data to our prediction. And the deliverable will be that final model. And it should be able to, yeah, predict depression from sort of Reddit posts and make the distinction between depression and other mental health conditions. So yeah, that's it.
Fantastic. Thank you very much. What an interesting idea. Really, really nice use of just let it play out, right? Yeah, okay, no, brilliant. Thank you very much. Yeah, really interesting, and I really like that you've really thought through the process, but also this is a really interesting use of text classification, going beyond just the sentiment analysis stuff that we looked at last week. So really like that. Thank you very much. Brilliant. Thank you. Okay, so next up we've got Antic.
Hi, yeah, that's me. My computer's been really slow. Sorry. I'll get this up as soon as possible. So we have done something pretty similar, actually. We are doing stress prediction using subreddits. So we found a nice little data set on Kaggle, which is a load of subreddits and a kind of binary indicator of whether the poster is exhibiting signs of psychological stress or not. So we quite like this because we wanted to do some kind of binary classification model, and we talked quite a bit about it being interested in mental health and social media. There's lots of stuff we could do with this data set. So it's got some interesting features, like it's got a timestamp variable, but it's a kind of weirdly formatted timestamp variable. So there's some interesting kind of feature engineering we could do with that. We also thought that there's potentially some kind of interesting real world application to building a model like this that you could use on something like survey content or patient notes or something like that as well. So we've got kind of 3 research questions, again, sort of similar to the previous one. How feasible is it to do this? How feasible is it to build an NLP model that successfully predicts stress based on subreddit content? And then we wanted to look at, does the accuracy of that model vary by the subreddit topic? And also, how does the likelihood of posting that exhibits stress varying over time of day using that timestamp variable? So I won't go through too many of the steps because they're quite similar to what was said before. But yeah, we've got some interesting kind of feature engineering stuff we want to do with that as well. And the idea is to produce a stress prediction model that's based on sentiment analysis, kind of neural network. And then visualize also the relationship between what we're calling stress posting, which we think we've come up with a new term there, and the time of day or the subreddit theme as well. And then we want to think about how we could deploy a similar kind of model in other contexts, particularly in a healthcare context.
Brilliant. Thank you very much. Sorry, music's going to play. Hang on, just give it a second.
It's all right.
Sorry, here now. Okay, excellent. So, brilliant. Again, a really nice creative application of NLP. I really like that. Again, another way of thinking outside the box of text classification. And I really like that you've thought about some of the additional things that you can pull in, like the timestamp information, to come up with some really interesting research questions. So, yeah, really well thought out. Really like that. Thank you very much. Brilliant. Okay, next up we've got Arm.
Hey, that's me. Can you hear me?
I can, yeah. I'll just pick a music.
Can you see that? Okay.
No. Oh, hang on, something's coming up now. There we go.
Now?
Yeah. Yeah.
Okay,
Brilliant.
nice. So we also went mental health, which at the time seemed like a nice original idea. And we came up with these questions. So basically, can we train a model to look at kind of different, I guess, to kind of diagnose people almost, but from various text statements that they put in. And then can this be used to identify the prevalence of mental health conditions? And then can we maybe look at some trend analysis over time? And what other kind of data sources could we use to kind of have a look at that? And we also wanted to have a look as well to see whether it was more accurate for different conditions. So our initial data set is an already coded sentiment analysis that's coded free text statements. And then our kind of stretch goals after that are to look at other mental health data sets that aren't kind of manually labeled or already coded, maybe come up with a chat bot as well, like an interactive Streamlit app or something. And then also maybe look at some other slightly more fun things, song lyrics, books, to see if we can apply the model for that. So our plan is standard kind of ML plan that we've been doing over the last few weeks. And then for our approaches, we're going to be doing neural networks, TensorFlow, one hot coding for each mental health condition, start with just one and then separate models for each. Yeah, and then that's it. Some other data sets as well after.
Brilliant. Thank you very much. Again, so this was, I really like that. So it's fine, you know, to do another mental health one. And I think, again, you've taken your own sort of angle with that. I really like that in that one, you're sort of pulling in aspects of some of the other stuff that you've looked at in the course, like the one hot encoding, etc. And it's kind of using NLP to try and enhance a traditional ML approach. Oh, that's quite.
Thanks.
I didn't know what they sound like until I played them, so there we go. That's very sinister. Okay, really good, really brilliant, excellent. Thank you. So sorry, I'm just trying to do a million things. I was making notes on all these fantastic things. Excellent. Okay, so Denise, up next.
I think that's me. Let me just. Okay. So. We doing a little bit of a throwback to the theme park stuff that we did quite a while ago with the discrete event simulation. We found a big data set with 42,000 reviews of 3 different Disneyland branches. So we thought we could do a few different research questions, starting quite simple, of which of the 3 parks is sort of preferred and where are the reviews stacked towards. And can we predict then the user rating from the text review? So doing a bit of sentiment analysis on that side. And then we thought 3 and 4 are slightly far-reaching, and whether or not we'll get there, we're not, 100% sure. But we think we'll split up our group to try and see if we can tackle these things. So determining a theme park choice for a user based on their priorities and time of year that they're visiting. So we can use things from the word cloud that we generate in the first step to see what kind of things are important in positive and negative reviews, and then ask a user, what would be important to them on a ranking scale, to then return which park they should go to. So we've got a very simple structure of what we want to do, but start with a little group activity of pre-processing the data because it's not pre-processed, analysing it simply, so looking at average ratings per park, and then sort of visualising the data and looking at word clouds of positive and negative reviews, and then using language processing to get sentiment analysis to sort of predict where the review if a review is going to be a positive or a negative one, in the final rating. And we also thought we could use undersampling to try and promote the ratio of positive to negative reviews, because it's Disneyland, so everybody's a bit excitable in their reviews and they're quite stacked towards the positive. And then finally, this is where it gets a bit more complicated, looking at whether or not a user can give us a few things important to them on a ranking scale, and then sort of return an output on which park to go to. That's our sort of optimistic end goal.
Wow, fantastic! Thank you very much. That's amazing. Such ambition shown in that project beside that. Okay, so I'm just entertained by these random noises. Yeah, really ambitious project. I can't wait to see what you come up with by the end of the day. Some great stuff. Really liked the fact you're going into a bit of multi-label classification there as well. Thought about how you might undersample. We thought about that might be an issue because of the real world data. That I really liked that, and it's just a really nice creative way in which you can take these natural language processing approaches into a different direction. So really nice out of the box thinking there. Thank you very much. Fantastic. Okay, that was Denise. So Motorola, you're up next. Let's see what random sound you'll have. Oh, you're muted, by the way, just to let you know.
Hi there.
Hi.
Okay, can you see this?
Yeah, that's all come through.
Okay, so the data set we're using is the Supreme Court judgment prediction data.
Okay.
And so the question is, can we apply a natural language program to the fact column within this data set to predict first party winner? The approaches we'll use is using NLP techniques to find features within the text that can be put into a machine learning model to predict outcome. So we're going to load the data into a data frame, pre-processing the facts data to remove stop words punctuation and move to lowercase, doing an exploratory analysis via word clouds of the winners and losers and the different areas of law, and then use bag of words with count factorizer, named entity recognition, and then put that into a predictive model.
Brilliant, thank you very much. Okay, that was short and sweet. Got to the point. Brilliant, yeah, really nice application of that, those approaches to that data set. I really like that. Nice that you'll be looking at some of the, in fact, quite a few of the different approaches that we've covered in the last few weeks. So it'll be interesting to see how those kind of things apply to that data. And again, nice that you're thinking about how those techniques might sort of enhance traditional machine learning approaches. So yeah, really nice, fantastic. Thank you very much. I will. I think I've cancelled. There we go. I think that will stop it coming through. Brilliant. Okay. Right, where are we? Motorola. So Paula, you're up next.
Hello, that's me. Hang on. I'm getting there, I promise.
Yeah, that's okay. The suspense is killing us.
Can you see my screen?
I can indeed.
Excellent. So this project is called the Routepulator, mainly because we all like a pun. So the Roup is the name of an operation, and calculator implies that we are going to try and predict how long an operation takes. So I asked the question about whether we can use our own data set. So we are going to do that. I've presented this data before. It's completely anonymized. So that's fine. And I'm happy it's spread all over YouTube. So the problem is that there are lots of people who need treatment in the NHS within urology, 400,000 individuals, of which there are many people waiting prostate cancer operations. Prostate cancer incidence is ever increasing. Theatre time is a very precious resource, and it wouldn't it be nice if we were able to allocate our resources much more efficiently than we currently do. So what we would like to do is to create a machine learning model in order to predict how long an operation, specifically a prostate operation to remove the prostate, will take based on a number of known patient factors. So that's the first half of the project. Then the second half of the project would be to create a natural language processing model in order to pull the relevant features for the machine learning model. And that would be based upon the patient's letters. So ideally, we'll be able to feed in a letter. It would be able to pull out all of the pertinent features and information, and then spit out how long an operation will take.
Wow, that's certainly ambitious. Thank you very much. Again, a really creative proposal here. I really liked the. I mean, that you could do that as an HSMA project, and I salute your optimism for trying to do this in the next 4 hours. But again, you know, even if you can get to a kind of proof of concept, I think that would be great. But yeah, really interesting and fantastic. How you've thought about how you would kind of weave natural language processing into more traditional machine learning. So I really liked that that hybrid approach. So yeah, really nice. Really like that. Brilliant. Thank you. Pokey, you're up next.
Just share my screen.
You're all sticking very well to time. I think it's because you don't want to hear the ghastly sounds that this app is making.
Right. There we go. Okay, so hopefully you can see my slide. So we are going to, our team, Pokey is going to develop a toxic comment detector, so sticking along with the theme of mental health that's been going on today. So essentially it's based on the fact that many users get exposed to, on news and social media channels, quite toxic comments within the comments section. And viewers may not be explicitly aware of these comments. We're thinking of patients who may not have English as a first language, or potentially children as well. So we want to really develop a model which can identify and alert the viewer as to whether or not there is any toxicity within the statements that is being presented in front of them. And this is hopefully going to be split into subcategories on toxicity. And the way we've done this, or the way we're going to do this, is we're going to utilize train a model using the YouTube toxic comments dataset, which is freely available on Kaggle, which naturally splits. It's given a comment and it splits it into multiple different classes. So we're working on multi-class rather than just a simple binary classification model as to whether or not it's toxic, if it's abusive, if it's threatening, if it's provocative, if it's obscene, sexist, etc., etc. We're going to then take that trained model and then apply that to initially news headlines, but if we can find a data set that contains comments or social media comments, that we might apply it to that as well. And the idea behind the use of this model and the output is to when a comment is presented, is to identify if there are any toxic traits within that headline. So it'll hopefully spit out a percentage of how, you know, sexist or racist the comment is, but we can then convert that into a star or maybe a traffic light system, which then can be a bit more user friendly for the end user, be it a child or someone who might be using the site. And that's our pitch.
Brilliant. Sorry, thank you. I was just in the middle of noting down. Again, amazing application. Really nicely. And I really like the way you thought about kind of the real world problem and then how you might engineer a solution to that using these approaches. I think that was really well thought out. And yeah, I can't wait to see what that comes out with. I think got some really interesting stuff that you can explore there. So really well done. Fantastic. These are amazing. These are genuinely amazing. Right, Sid, you're up next.
Yeah. Have I shared the right screen? Hopefully you can see my slide. Google Doc, yeah. So yeah, we want to look at emotion recognition as applied to healthcare related data. So found an interesting data set with like emotion categorization, and so we wanted to train our model using this data set and then apply it to some healthcare related data. So we were looking at some drug reviews. We found a good data set of drug reviews, or also looking at hospital reviews. And so the research question we have here is, what are the emotions that are driving reviews related to healthcare? So in the context of the hospital reviews, it could be like, are people angry about food? Are they happy about the nurses? And we thought in quite a simple way, we could just use a word cloud for each emotion and kind of understand how people how people yeah, like the way people feel, how does that relate to different things? So kind of as an extension, we could look at some named entity recognition, but initially we're looking at using Python and TensorFlow, a TensorFlow emotion recognition model, making some word clouds, and kind of our word clouds are currently our key output. So that, yeah, we've got some actions we're going to do. So basically we need to train the pre-processing data, pre-process the training data, then train our model, and then apply that model to some healthcare data, and then filter by emotion and create word clouds. And so that's kind of our linear steps, but then we need to the pre-processing for the healthcare data we're going to do as people have capacity over the day. So yeah, that's our plan.
Fantastic, thank you again. A really, really creative thing that you've come up with here, and I really like that you've gone out and found a sort of data set and then thought about how that might apply to some of the stuff that you've got, and thought about how you'd sort of engineer that question. So I really like that sort of two-step thinking you've gone there. You know, what are the emotions driving these reviews? So yeah, really nice. I really like that. Fantastic, thank you. TIA.
I think that's me. Bear with me, I'm nearly there.
Yeah, no worries.
Okay, and hopefully.
Also, you get 5 points for correctly identifying the chipset.
Oh, I was going to say, is this fake news or not? You've ruined my first. Anyway, there you go.
Oh, sorry.
Yes, I believe that's why we're called TIA. We are named after a chip. Well, that's a few seconds gone. We're talking about fake and real news as well. So what we thought is, does fake news have a vibe? So is it more likely to express negative opinions? Are they themes that recur in fake news that don't occur or occur less frequently in real news? And how and sort of how similar do fake news items compared to real news items? So there's 3 steps here. Are they more negative? That's a sentiment analysis. What words, what vibe is named entity recognition and some n-gram analysis, and how similar are some cosine similarities. So we thought of 2 data sets. We've got this rather lovely fake news classification that has 72,000 or so articles, split pretty evenly into fake news and non-fake news. And then what we thought for the sentiment analysis, we were looking for a data set. We found this Twitter sentiment analysis, which classifies Twitters into positive, negative, or neutral. So what are our approaches? Well, the first one is to create and apply a negative, positive, neutral classifier, probably a neural network-based one. In parallel, because we're looking at each sort of fake news data set and real news data set, is the possibility of finding the named entity recognition work and word cloud work. And the last step is a sort of a compare and contrast of everything. What do fake news looks like and real news looks like? So that the outputs will be a model, which would be notionally shareable. And the stretch goal is to go from positive, negative, neutral to an emotion-based one. Some lovely, pretty nice word clouds and some very clever graphs, such as these comparison ones. I'm trying to remember what they're called, the cosine matrices, or some pretty graphs that we'll share with you.
Perfect. Thank you very much. Again, really, really interesting. I really like that. A really creative idea to think about, excuse me, not just fake versus non-fake, but thinking about, well, you know, can we classify the text in a different way? Are there aspects, characteristics of fake versus real news, and using all of the kind of approaches that we've taken to kind of explore that in a very data sciencey way. So I really like that. Very, very creative. Thank you very much. Okay, we then got Zilog. Just to flag up, RJ McCall, if you're happy to present, pop in the chat, and Sammy can let me know in a second. You don't have to, but if you'd like to, certainly we've dropped in. Sounded like you've got a really interesting idea. So, but let us know if you want to do that. But Zilog, we've got up next.
Hi. So Dan, I think you came into our group when we were discussing our ideas, and we originally were going to do this one on NHS England, but there wasn't a labelled data set, and so we chickened out. And we went back to our ideas and re-voted with ice creams. And with ice creams, we chose the sentiment analysis of Hansard. So what we're looking at in Hansard is looking at conflict in Parliament. So what we're going to take is the labelled data set of speeches in Parliament. So they're labelled as to whether they're speaking for or against the government, as to whether they're essentially positive or negative for the motion that's in debate. And we're going to then apply that to a much larger unlabeled data set. And we're going to look at changes in time to see if we can predict, see if changes in rebellion, that's speaking against your government, will predict the likelihood of an election upcoming, and also if the sentiment concordance between the opposition and government changes over time. We've got quite a lot of ideas as to how to move this over and how to move this on. And this is not a Kaggle data set, it's from Mendeleev instead. And so we may be able to apply this further to actually generate some further data sets of our own, because the current data sets only got to 2019 that have been published, but the sources of them are available, and we should be able to find out how to scrape that if we have time and if we can divide our resources appropriately. I rest my case.
Brilliant, thank you very much. Again, really, there's such a diverse range of projects that have just been pitched. Absolutely amazing. You all continue to blow me away. I mean, genuinely, absolutely stunned by this. Yeah, again, really, really creative, really different kind of approach. And I really like you've taken that sort of, as a number of groups have, that kind of multi-step thinking of thinking, well, we can apply this in this way. But then that would enhance this kind of analysis. I really like that. So lots of sort of potential questions that can grow out of that analysis. So yeah, really creative. Really like that. And again, you know, as I sort of mentioned when we came in, no shame in changing the tact if you don't think something's going to work. That's part of the process, and you will encounter this in real world projects. So I think that's a really strong move that you've done there. So really well done. Brilliant, thank you. Absolutely amazing. So Sammy, did we have a decision on RJ McCall if they want to present?
RJ McCall will not be presenting today, but
No,
I can definitely say that from what I saw, they've come up with a really cool idea. So yes, I shall leave it.
Yeah, absolutely, and it did look great. So well done, and I look forward to seeing how that turns out as well. Fantastic. Okay, well, Sammy and I now have the incredibly difficult task of trying to pick even 5 of the winners from that. Is difficult enough. Yeah, absolutely. Genuinely, I think I speak for both of us. Absolutely blown away by those proposals. That is far more than I thought you'd come up with. So really, really good. How far have you come in 4 months to go from, you know, hello world to this in such a short space of time? So amazing work. Okay, so what we're going to do, Sammy and I have made some notes. We've got a little secret shared spreadsheet where we're making notes on this kind of stuff and which ones we're going to award points to. We'll announce that shortly on Slack once we've decided the top 5. We'll put up that announcement on Slack. But for now, I'm going to open up the breakout rooms, and you are going to go forth, and you will be in your breakout rooms for just over 4 hours until 3:30. You can use that time however you like. You're now going to try out your project ideas, and you're going to work on your projects. Don't forget, you do need to come up with a 5-minute presentation as part of that. So in the excitement of the project, don't forget to do that. Collaborate, make sure you've got somebody sharing a screen, make sure you're talking as we're going to be floating around, we're going to be making notes on things we hear, so make sure you're doing all that too. Use everyone in the group to the best of you've got big ambitious projects here. Don't worry if you don't manage to get it all done. These are pretty ambitious, but use your resources, so get people working on different aspects, and use your time wisely. You've got just over 4 hours, and I cannot wait to see what you come up with by the end of the day. So let me stop talking. I will open up the breakout rooms and go and have some fun.
I shall.
Thank you, Sammy. Well done. You are now being recorded, so everything going out on YouTube.
Okay, I'll just share my. Can you see that?
I think it's just coming through. Yep, there you go. And you're all set.
So we had some problems. We fell at the first hurdle and couldn't get the collaborator live share thing to work. So we spent quite a while trying to sort that out. Essentially, our project was supposed to look at whether you could identify depression and distinguish it from other mental health conditions using sort of neural network kind of approach. We didn't get that far. We struggled to sort our data out. We struggled with the processing. We had the same problem that you said about trying to get our data in the right format. And essentially there was only really 4 of us. So, and I would say of that, 2 competent people. So all we've managed to get out is these word clouds. So essentially on the left, these are words that are most common in the subreddit posts that were marked as sort of depressed. And then on the right-hand side, these are the words that are most common in the sort of not depressed subreddit posts. So we can see they are quite different. There is things about work and stuff in the not depressed, but it's a bit more varied, whereas actually depressed, you do see a lot of common words. So knowing, feeling, wanting, kind of life, people. So it probably gives us some insight into there are differences between the posts of people with depression and people who are not depressed, but that was unfortunately as far as we got. So that is my entire presentation, unfortunately.
That's okay, no worries at all. Look, part of the experience of today is indeed trying to get a bit of a trial run for the kind of thing that you're going to encounter in your projects. And I can guarantee you, every one of you will start off on your projects with a bounce in your step, thinking you're going to change the world in a few days, and you will run into all sorts of very, very dull problems that take a long time to fix. So this is good experience. I would say fantastic word cloud generated there. Really interesting way in which you sort of captured the differences in common words that are coming out, and really nice to see some insights as well coming out of that. So even in spite of all the setbacks, you managed to come up with some really interesting insights. So well done and great work. And I know, as a lot of you had issues and had to pivot and look at different things. So really, really good work. Well done to you. Okay, we will move on then to Antic up next.
Yeah, that's me. I'll just share my screen. Okay, so has that come through? Yeah.
Yeah, that's all come through.
Cool. So yeah, this was just the slide that we presented earlier. So we also had some issues. We were trying to predict whether subreddits were indicative of psychological stress or not stress based on this Kaggle data set. We had some problems. So we did spend quite a lot of time trying to make VS Code live share work, which did take us quite a long time. But we managed to eventually get it working for most people, not for everyone, with a Python notebook file. We had some help from Zilog and Don Rowney, thank you. And then we had a look at the data set with a word cloud. So we assessed the whole data set and then added a few more kind of custom stop words. And we ended up with this, which is kind of interesting. So obviously there's some words in here that are maybe not massively surprising when we're thinking about subreddits. Things like feel but help is also really big, which is kind of interesting. And then there's some other words in here that kind of indicate the topic area around stress. So we've got like anxiety, relationship, work, friend, that kind of thing. And we also turned it into a face shape, which is cool. And then we did quite a lot of like feature engineering and pre-processing stuff. So we were trying to sort of turn, in order to do the word cloud, we had to put all the text into a single string. So that was fun. And then we had this timestamp variable, which was an epoch time, which I learned today is like the number of seconds since the epoch, which I'm not sure when that is. And then, yeah, we used these different functions to convert that into like a nice year, month, day, and hour, minute, second variable, and then we group that into hours and into sort of times of day, like morning and afternoon and stuff. We did have to assume a time zone for that, which we've assumed is a US time zone, but yeah. And then we also simplified the subreddit sort of themes to sort of combine them into something more meaningful. So we did do some looking at what the data actually looks like when you do that. So this is kind of interesting of like hours in the day when posts are happening. So you got kind of peaks in late at night, which maybe makes sense for some of the topic areas, and then this kind of peak around like lunchtime, and yeah, a bit more consistency over the afternoon and evening. So that's kind of interesting. We also looked at the subreddit themes, and this I think might give us an indication about how good the underlying data set would be for training a model you could use on something else, because it obviously clearly draws posts from subreddit themes around abuse, relationships, and mental health, which maybe means that if we trained this model and then tried to use it on a much broader set of subreddit data or some other kind of data, then it might not work quite as well, because the underlying data set is kind of obviously geared to these topic areas. But yeah, it's kind of interesting. And then we looked at sort of these broad times of day, so that kind of reflects what I was talking about before. There's this big jump in posts in the afternoon, but yeah, maybe not quite as much variation as you might expect over times of day. So that we did try building a sentiment analysis model, and the idea was to build a neural network that predicts whether each post indicates stress or doesn't indicate stress, and then compare that to the actual labels for each post. But we had some issues, like other people said, with getting it into the right format. But we did write most of the actual code for kind of getting the model set up, vectorizing it, training it, and we followed some examples that we think are what we're trying to do, but we couldn't figure out how to make them work. But yeah, we might try it with the stuff that TIA have developed as well. And then live share crashed at about 3:15. So from that point, we sort of, we went and had a cup of tea, I think. But yeah, so some good stuff, and we think we might ultimately be able to get it to do what we want to do. But yeah, the underlying data set in itself is quite interesting.
Yeah, fantastic. No, thank you. Yeah, again, really, really interesting insights you managed to pull out there. I think just from that sort of simple preliminary analysis, even without sort of exploring a bit further, but definitely your instincts were right to look at some of that that timestamp data, etc. as well. But really interesting to see how you picked out some of that, some of the themes, etc. that were coming out. So yeah, it'd be great to use kind of Stuart's code to hopefully get your sentiment analysis. Hopefully you can then just plug in pretty much as we did in the lecture last week, and see what comes out of that. So that will be really interesting to see the outputs from that.
Yeah.
Brilliant.
Yeah, I think we've got someone working on that already. So yeah, we'll see what happens.
There we go. There we go. No pressure, but if you can get it ready in the next 45 minutes, great. Brilliant. Thank you very much. Again, a really, really interesting. And it's worth flagging up that you basically had 4 hours without lunch to do this. So assuming you took at least some sort of lunch break, you've all had about 3.5 hours to do this. So pretty impressive, I think, the outputs that you're coming out with. Fantastic. Okay, so Arm, you're up next.
Hi, that's me. I'll just share my screen.
You're all keeping very nicely to time as well. This is you'd never make good academics. We never keep to time.
I hope you can see that.
Yeah, that's come through okay.
Great. So what did we actually manage to do? So this morning we'd identified that we wanted to use the sentiment analysis for mental health, which is a really good data set where we have statements and then everything's categorized. So there's 7 different categories, which includes depression, anxiety, stress, suicidal, personality disorder, quite a range of stuff. We started off with some word clouds to see how similar the words were across all of them, and what really jumped out to us was they all contain the word feel in quite a significant way, and some of them even very usefully included the keywords, so bipolar or anxiety or stress. The normal data set didn't include feel. It was quite small off to the side, so we knew that those were different. And then we started off wanting to do the TensorFlow sentiment analysis and thought we would break down our data into just take the depression and normal categories and try and see if we could tell the difference between those. And we did some really good data prep, but that didn't all really go to plan because we had the same problems as everyone else with TensorFlow, because we didn't have everything as individual text files. We'd also decided to explore separately if there was a way to categorize stuff rather than just having that yes or no question. And we came onto a technique called multinomial logistic regression, which I guess is the next step from our logistic regression. For example, we did on the Titanic data where we had died and survived, but this technique does categories. So when there's more than two possible outcomes. So Sid had used a technique to vectorize the text data for machine learning, and did the usual model where splitting into testing and training, and used a technique called label encoder to convert the text labels to numerical. And we were really impressed. This looked so good. We did the confusion matrix and we found a really strong relationship between the predicted and the true. So you can see really strong for normal, anxiety quite strong as well. There is some mix up between depression and suicidal, but we thought those probably do have some very similar phrases and keywords in those. And that was our accuracy as well. We managed to evaluate that. So that was 75 overall, different for everything. Maybe a little bit less strong on recall for some of them especially. So in the questions that we did from this morning, yep, we could train a model to identify various mental health conditions from text statements. And we thought, yeah, it does work better for certain mental health conditions. We felt more confident about it, identifying anxiety, depression, or suicide if that was grouped or normal. So wild idea this morning, could we train a chatbot to identify mental health conditions and provide resources? So I'm going to hand over in a minute to Sid, who has done a bit of a prototype chatbot. And we've also thought about some of the ethical considerations of that. For example, because depression and suicide were mistaken for each other, we should be providing proper suicide information. This is the first step and not a replacement. And we did use trusted resources such as NHS websites, doesn't replace any existing tools. And would it be appropriate to expand to other physical health conditions? Perhaps yes, perhaps no. But I'll stop sharing my screen and I'll transfer over to Sid, who's got the app running on his PC.
I'll just for fairness pause the timer a moment while you switch over.
Yeah, I hope you can see the screen.
Yeah, that's come through.
So we built a very basic chatbot or chatting interface on Streamlit. So if and these prompts have taken from a separate data set, which consisted of usual tweets from certain time periods. So if we use them here and click on classify, then so the chatbot classifies it on those categories. So here we can see that it's classifying it as anxious, and there's some more information where it takes them to the NHS site, which is dedicated towards anxiety. If I put a normal prompt in, so let's see what it classifies at. So it says you're doing quite well, so everything is good. So as Steph mentioned, there's still ways to go for the model to be classifying correctly. So this one is quite evidently suicidal, but if we classify, so it classifies it as depression. So we can see where the model lacks there. And I'll just test out one last simple response in there. If I just type in I feel lonely, so it classifies it as depression as well, and it takes it to the related site. That's it. Sorry, Dan, we can't hear you over the alert.
Oh, sorry. Can you hear me now? Yeah, brilliant.
Yeah.
Absolutely amazing. Again, I re-emphasize the words 3.5 hours, basically, and I'm astonished with the amount of stuff that you managed to do in that time. You had some beautiful word clouds. You then went on. You pivoted. Running into the same issue that a number of groups did, and thought, well, let's have a look at a logistic regression type approach. Came up with these amazing confusion matrices. You had some really interesting insights come out of that, and then you chucked in a prototype chat box, a chatbot on top of that, which already looks quite promising just for that prototype. It's a really nice use of Streamlit, which you haven't been taught yet. And what I loved about this was that you also gave a mention to the ethical considerations. You identified the kind of stuff that you would be doing, and that there could be real ethical problems. So you need to be very careful how you approach this with people that are going to be very vulnerable potentially using this. But I absolutely love that. Really well done. Such amazing work. Yeah, excellent work. Really well done.
Thanks, Dan.
Brilliant. Thank you. So who were you? You are, weren't you? So Denise, you're up next.
Hiya, just getting the screen sharing.
No worries.
Go. Is that okay?
Yep, that's come through.
Brilliant. So yeah, we were looking at the Disneyland reviews for the theme parks. We had our research questions of which parks are better, can we predict the user ratings from the text, and what theme park choice would someone want to go to. So we worked on pre-processing the data first, looking at how many different ratings we had for the different reviews, and then we tried to simplify them by grouping them together and sort of a dictionary where anything that was under 3 stars essentially became a negative review, and anything over 3 stars became a positive review as a way to group them together. And then we encoded the data by branch, because there's 3 Disneyland parks, Hong Kong, Paris, and California in the data set. And then we basically had a much more simplified data set to work with. We created a few bar charts of the average review by Disneyland theme park to see if there was any significant difference. Obviously, Disneyland Paris, bless it, lagging behind. And we looked at the number of reviews by Disneyland theme park again, so California by far being the most popular. And we also had a look at where the visitors had come from and the theme park locations that they went to. So overwhelmingly, the visitors were from the United States to the California Hong Kong theme park, which might explain why generally there's more reviews for that theme park, and they're more positive. And again, similar data set, number of reviews by location for each Disneyland theme park. So we had a bit of chance to play around with the bar charts for this, which gave us an idea of the data set we were working with. Hannah is going to talk a little bit about the word clouds as well.
So we made looked at the data from several different perspectives, and the word clouds were really useful for this. We looked at general positive, general negative reviews, then split them down by each park, and then by positive and negative reviews per park. So green shows the positive reviews, and then the red is the negative reviews. And we looked at it per park. We had to remove a number of different words in addition to kind of normal stop words. So Disneyland, park, ride, kind of were the main ones that we had to look at. What the initial kind of word clouds really showed is that there were quite similar themes coming up in the positive and in the negative reviews. So particularly rides, and the names of the different parks, because people would often write things like, oh, when I was in Hong Kong, it was much better than I was in Paris. And the rides were particularly kind of prevalent. People saying, oh, the rides were good, the queue with the rides was long, or the queue was really short. And so that gave us a clue that it might be a bit difficult to kind of predict from the text. But generally, looking at Hong Kong, people were talking a lot of the things about the food, and about the queue times and kind of in the poor things, and then kind of general kind of positive words about kind of positive reviews. In Paris, apparently they have quite good queues, but you can see that queues it really depends on the day, and the people and the food seem to be quite kind of a poor thing in Paris. And then in California, it was there were obviously quite a few days where they had a lot of things were closed, so people got really cross that they couldn't access various different bits. But again, general kind of seemed to be kind of quite positive in crowd control. But the real thing that we really drew from them was that there were a lot of themes which were similar. Either things were open or closed, lines were good or bad, the rides were either good or bad. And so it was a lot of the same themes in the positive and the negative reviews.
Okay, I'm going to try and rattle through the model in 40 seconds, but essentially we then went from that and we used this linear SVC model. We used a different model because of the TensorFlow issues. If you just skip to the next slide, Emma, just to show you the outputs. So we managed to create confusion metrics, and what we found is that we were very good at predicting the positive reviews, which is 0.95, but the 0.62 shows that the negative reviews, we were finding it challenging to identify all of them. So if you just skip ahead 2 more, Emma, I guess the future developments, the next one is to kind of look at how we can improve the model's identification of negative reviews, amongst other things.
Sorry, I was trying to stop the music. You can't stop it once it starts. Sorry, finish your sentence. That's okay.
So yeah, we I guess the main purpose of this is then to then apply that model once it's trained with a better view of identifying negative reviews to social media data, because then you can pick out themes of negative and positive reviews without having that rating that we already had in our trained data set.
Brilliant. No, absolutely. Again, absolutely bowled over with the amount of stuff that you've managed to achieve there. Again, in 3.5 hours. I mean, honestly, I routinely spent 3.5 hours staring at my code, wondering why it's not working. So to see that you've achieved all of this, you had some really nice pre-processing considerations. It was really nice to see right at the start. Really interesting use of the bar charts as well to get to that initial analysis. Those amazing Mickey Mouse word clouds, which were so effective, simple and effective visualizations that really brought to the fore the kind of the big conclusions you were talking about. But then, to go on and then use a different kind of model and find out, so what the, not just looking at the kind of the base level accuracy, but also looking at some of those other metrics and say, actually, we're pretty good at this, predicting this, but less good at this. Again, fantastic insight. So really, really good, really good work, and exactly the kind of thing you need to be doing as data scientists. So amazing work. I can only imagine what you'll be doing in your projects in phase 2 if this is what you do in 3.5 hours. So yeah, absolutely brilliant. Fantastic, thank you. Okay, so Motorola, you're up next.
Hi there.
Hello.
Just share the screen. Cool. Is that coming through? Okay. Fantastic. So we looked at the Supreme Court judgment prediction data set, and this was looking at applying natural language processing to predicting first party winner from the data set and using the techniques, a bunch of different techniques with natural language processing to put that into machine learning to predict the outcome. This was our initial vision of everything. And the plan of action, this was from the earlier slide, but loading the data, processing it, and then doing some exploratory analysis followed by the predictive modeling side. As with other groups, we did hit some roadblocks, and that included the CSV to text issue, where we were trying to run some of the word cloud models and the analysis for that, and we're having some issues where it needed to be in the dot text format rather than the CSV that we had. So we got around that by reformatting it to export it again as a .txt and then reading it back in. But it sounds like there may be other instances and different ways and methods of doing that also. From the findings of the word clouds, we broke down looking at the winning cases against the losing cases. There were some differences, but not anything which showed initially very obvious patterns from this, looking at the exploratory analysis side, and we would have explored hoping to break it down to like a category or a type of case if we had more time also. And I will hand over now for another part of the analysis, which was the named entities.
Yeah, our group, we broke into a different subgroup and we looked at the named entities analysis. We had the same problem where we were struggling with the CSV. But then when we checked in again with the other group, we found that they'd had the same problem. They'd already managed to get it into a text file. So we were able to steal that bit of code and put it into our group's code. Then we had the problem that we had too much data and the RAM ran out, so hence the angry RAM on screen. So instead we took a sample of the data, so we just brought out 10 just to check that it actually worked, our method, and when we reran it, we actually got an output. So what did we find? We've got the output there on the right, and it did seem to be grouping things into the right entities. So we want to use some of those features for like a future predictive model. And we also noted that some of the states in particular were coming up in the word cloud. So we just need to understand going forward, if we were going to link those two together, what that actually means and what we can do with it.
So we broke into another subgroup and we looked at the bag of words. We had the same issue as well with the text and the CSV file. We got around this by creating a new object which just read in the column that we needed rather than the entire data set. So from this, we then created a bag of words with the entire data set, but with, I think it was 3,000 case files and a lot of words. We couldn't really get much from the data. So then we decided, oh, we'll look for at the data that had a first party winner, we'll split it, first party winner and a non-first party winner, we'll split it and see what the similarities are. Cases where you had a first party winner, are their case files more similar? And similarly, those where you didn't have a first party winner, are those case files more similar? We managed to do that, but again, we just had these massive matrices, which we couldn't really read much from. So I think future development wise, it would be to try and create some summary stats that we were better able to compare them. And then also the idea was that we would use this bag of words and the vectorization of them and put it in a model to predict the outcome of future cases.
Thank you. So in summary, there was some of the areas of the aims and the overall vision that we weren't able to hit, but it was really great being able to work as a team. It did take some time for the collab live side, but working together to resolve and get to the analysis that we had.
Brilliant. No, thank you very much. Again, really amazing stuff. You did lots and lots of different things there. And again, what's coming through so strongly with so many of these presentations is that kind of resilience. You all ran into issues, some of them, common issues, others more sort of unique to your particular data, and found really creative way. I even like the fact that in your group, you found two different ways of getting around the same problem that you had, which was really nice. I think really nice reflection on the limitations. Yes, indeed, that is an issue with bag of words, which is why it doesn't get used for complex analysis, because you just end up with these huge sparse matrices that are very, very inefficient representations, and why things like TF-IDF, etc., vectorizations tend to be better choices. So, but yeah, really nice the way you reflected on everything you've done there. Some really nice word clouds again at the start. So yeah, really nice work. Really liked that. So thank you. All okay, right. So we've got Paula up next.
2 seconds.
Yeah, no worries.
Can you see my screen?
We can indeed.
Excellent. So this is the Rapulator featuring natural language processing collaboration mashup mix. So just as a reminder, the problem is with theatres, there's limited resources in terms of theatre. And there's unlimited demand seemingly at the moment of need for individuals who need operating. And what I think and what other big organizations think is poor theatre utilisation. So how can we become more efficient? Well, is it possible to predict how long an operation is going to take based upon known patient and procedural factors? And then can we go and make a natural language processing model which will be able to go through databases, patient letters, and pull out relevant features which might be helpful for a machine learning model? And then finally, can we create the ultimate collaboration and marry up a machine learning and natural language processing model? So with regards to the data set, this was collected by myself the old-fashioned way in the evenings, looking over hundreds of patients' notes, cross-referencing it against operation notes and procedural factors, which took a long time. The output or the independent variable in question was the actual operative time, and I pulled out multiple features related to the patient and the procedure. We used a simple logistic regression model as we were predicting a continuous variable. Others are available with a 75-25% test train set. We initially got an R squared of 0.35, but I know we can do much better if we have a bit longer. Then for the natural language processing, well, you mentioned that there are plenty of versions of spacey out there, including medical ones, and I see you can train your own ones, but that would take a very long time. So we are looking for very, very specific phases and keywords within letters and databases. So I thought I would customize a spacey natural language processing model. Here is an example of a letter. So as you can see, very, very specific, unusual doctor shorthand information that we're trying to pick out and then shove it into the machine learning model. So I'm going to hand over to Rich for a live demo of our model. It's not as pretty, but it works. Rich, are you there?
Yep, just coming in now. Is my screen sharing?
Yeah.
Yep, wonderful. So right here, this is the letter. We have it set up so you can read it straight out of the CSV, but for now. And yeah, you just run it. Takes a couple of seconds at the moment. We get a nice little prediction of 189 minutes for this patient. You see, if we, for instance, change the age, change the BMI, a different PSI, maybe move the heart attack. And again, boom, get a slightly different time. One of the curious things which tallied up with what Jake had found when he'd manually done this is by far the biggest influence is what surgeon had been assigned. We just run through the huge differences here, like 100, just over 2 hours. This one nearly 3.5. So the way we went about this, we split into two halves. One half did the natural language processing, thinking through the letters. The other half built some models. As Jake was saying, we were in the process of refining this when we sort of run out of time and ended up just picking a model and running with it. It's currently still set up so it can just rotate through. It's just only stuck with one at the moment in this list models to test. And then at the end, like last half hour, we just grabbed the two halves, sort of mashed them together a bit, and yeah, got a nice little output. Using the same setup we've got at the moment, we can also at least attempt to predict things like dentistry, and that's the end of our time.
Brilliant. No, thank you very much. Again, I have to say, of all of the project proposals that were put forward this morning. I think it would be fair to say yours was by far the most ambitious in terms of what you're going to try and achieve. So it's amazing to see how much you have achieved in that time, and some really interesting, promising results from the machine learning work, and then really interesting insights coming out of that. I think such an interesting application of combining natural language processing techniques with machine learning to try and predict surgery time. It's such an interesting thing, and I think you got a really nice starter for this. It'd be fascinating to see how this plays out, because already you've got some interesting things that's picked out. You know, that the surgeon, which doesn't surprise me, that the surgeon is the kind of the most important feature in there. So really, really promising results. Can't wait to see more about that. So well done, everyone. Really, really, really good work. Brilliant, thank you. Okay, so that was Paula, so we're on to Pokey.
Right. I'm just waiting for the screen sharing to end.
Oh yeah, sorry, Richard, can you stop sharing? Oh, hang on, I can stop it. There we go.
Thanks.
Hello. So we were looking at NLP processing on toxic comments online. So the original statement was that we would look at some toxic comment data set from I think it was news headline, comments on a news website that had been labeled for various toxic traits. We were going to train the model on those and then apply that to a much larger data set of YouTube comments to try and flag up the various categories of toxicity that they may be labeled with. Do you want to go on to the next slide? So this is just sort of a breakdown of the data. You can see that there is about 10 tags at the bottom of various types of toxicity that a comment could have been tagged with. It's around 1,000 data sets, 1,000 comments from 13 videos. And one of the issues we found with the data set was that there is a relatively small amount of sample sizes for each of the different categories. We approached it by splitting into groups to look at different elements. Some of us looked at sort of the data analytics to produce this kind of output. Some of us working on word clouds to sort of analyze the different words that are in there. Some of us worked on a model, some on data formatting. And then we also had a look into sort of existing online models that perhaps looked at this kind of categorization earlier. Go to the next slide. So the first problem we ran into was that we realized that each comment wasn't categorized as just a single type of toxicity that could be tagged with multiple different categories. So something might have been tagged as toxic, provocative, and hate speech. So immediately that was an issue in terms of trying to classify the comments. One of the solutions we came up with that is to run each one through its own separate model. So it produced a loop that would produce a model that just predicted one of those individual categories that would then, on the test data, would then tag each new comment with whether it was a Y or no, a true or false for each of those categories. We did that just with a simple bag of words approach and a decision tree, partly because we were running so many models, we needed to keep the compute sort of usage down, but then also the advantage is that it would give us a very easily interpretable output, so we could understand exactly why each one had been categorized. We then also ran into the further issue is that the bag of words on the training data obviously had different columns to the new data that we presented to it. The workaround with that was that we filtered both data sets to only include words that were common between the two of them. So then we were able to run the model against a completely new set of data. A few drawbacks, but it was able to produce some results. You can see the accuracy scores there, and it was producing fairly reasonable results for a lot of the categories, although obviously the low number of positives in the data set and only using accuracy is potentially a bit misleading. And yeah, so that was the initial approach. And then I'll hand over to Jake to talk about the rest of what we did.
So as mentioned, because we only had 3 hours to put this all together, it made sense to take advantage of some open source models available online. Someone in our group found a Hugging Face model that was specifically designed to identify toxic comments. So we were able to create a larger data set of toxic comments by taking a Kaggle data set of YouTube comments based off videos trending in Great Britain. So we ran that on 40,000 comments, and we produced a data set of 3,400 toxic comments that we were able to output. We decided to make a word cloud for this new toxic data set, which we cannot show you, not because it doesn't exist, but because the output is truly vile. So here is a very heavily censored version of that word cloud with some supporting images around it. And just to briefly mention, in the future, while the immediate available model is better for use now, the multilinear one is better for further development in the long term.
Brilliant. Sorry about that. No, fantastic. Absolutely amazing work. Again, really nice to hear some of the insights that you were generating from that. I really liked the way in which you approached that as well by coming up with these alternative solutions based on the problems you were encountering, coming up with these separate models. So you almost have like a toxicity classifier, a racist classifier, those kind of single things, which is a really nice way to approach this. I liked the fact that you used decision trees as well, so you went a little bit different thought, again, a bit more thinking outside the box, and using one of those existing Hugging Face models as well, pulling a model off the shelf, and seeing what that comes up with. So yeah, really nice insights there. I've just noticed my face. Thank you for pointing that out. Just down amongst the cats in that slide. Brilliant, thank you. But yeah, fantastic work again. Amazing how you're all managing to do all this in such little time. Okay, we've got 3 presentations left, and I know that Sammy and I have already got a difficult decision. So hopefully you're all allocating your points as we go away through this. So don't forget to do that. And we've got Sid up next.
Hello. Right. So I'm going to apologise straight away because we do not have nice slides because they are about as finished as our piece of work was, which is to say we didn't quite get there. But we wanted to look at categorizing hospital reviews by emotion, and to start with, in that we found this lovely data set looking at classifications of tweets into 6 different emotions, so joy, love, sadness, fear, anger, and surprise. And so we took to TensorFlow and we started to apply that. We had quite a few issues around here, but we eventually managed to get something working with a few hiccups here and there. And so what we've got here is it's not very accurate at the moment, and one of the reasons for that is that we had to take quite a small sample of the tweets to actually get something that ran in a reasonable amount of time. We did do some tests with 15,000 tweets as opposed to the 2,500 that is in this particular run, and that significantly jumps the accuracy. So with a bit more time, I think that's something that we would want to do and run it across more epochs with different batch sizes and things like that as well. What am I saying next? So yeah, what this is doing is attempting to classify those tweets into the predicted emotional categories, and then we wanted to apply that to some hospital reviews from other data sets. And it's at that application where we sort of broke the chain and we were going to make some word clouds. And I think Ruth has some word clouds that we generated from dummy data. So I'll hand over to her to show the work that was done at that end.
Yeah, I'll just show once you're perfect. Yes. So yeah, as I say, it's an unfinished bit of work, but we found this data set of hospital, basically people's reviews of hospital. So there's some really nice text data here. So the plan was to use, you know, the model that we'd created to categorize these by emotion. So for now, we've just given them a random number, but then if we'd have got this working, we would have obviously had word clouds for every different emotion. So these are just filtered randomly, so there won't be any particular pattern. But we've got a word cloud for anger, which is like an explosion. That one didn't work very well. A word cloud for fear, joy, love, and sadness, and then surprise. So yeah, if we'd been able to apply the model to it, it could have been quite nice, but unfortunately we've had some difficulties.
Oh, sorry, you done? Sorry, yeah, no. Yeah, no, fantastic. Again, really nice. I have to full marks to you for getting a TensorFlow model working with that kind of data, given the struggles that a number of groups had. And I saw just looking at your code some really interesting ways in which you worked around that. So yeah, I think people will be looking at your code with a lot of interest. And I know you didn't manage to get it working in the time, but I thought your designs of the word clouds, I thought that was really interesting, and so it's such a creative application of text classification that goes beyond sort of standard sentiment analysis and looking at kind of the emotions and how different emotions play into the way in which people review things. I think that's such an amazing creative application for natural language processing. So yeah, love to see more of this. I think really good work, and again, amazing what you managed to do in that time frame with all the issues that you had. Fantastic, thank you. Okay, so then TIA, you're up next.
Brilliant, thank you. I will just share. Hopefully you can see that. Yeah. So just a reminder, our project, we were going to do a bit of a comparison of some fake news articles against real news to try and see if we can use some NLP sort of processes to help us sort of distinguish between the two. As we all know, that there's a lot of fake news out there, and any help we can get in distinguishing them could be useful. We sort of split our groups into our team into two main groups. First, looking at the sort of the differences between the data sources in itself, and whether there's so many clear language differences in the two. And secondly, we wanted to do a bit of sentiment analysis and see if actually whether we can categorize these news sources based on maybe their positive or negative sentiment that they're coming out with. So firstly, when we found on the Kaggle, we found a data file that had 72,000 different articles covering a wide variety of topics, with about a fairly even split of about 35,000 fake and real news sources to work with. The first thing we did was do some word clouds that looked at the pair of them. There's some quite clear similarities between the two, some words coming up commonly in the same one, particularly things like probably more common words in articles like said and won. But when we dig into it a little bit deeper, we do start to see some differences, maybe a lot more sort of ancillary words coming through in the fake news article. Trump, unsurprisingly, coming through quite strongly, but also things like White House, New York, United States coming up really strongly as well. Whereas in the real words, there's only a few that really stand out. Everything else is a little bit sort of behind the scenes, I think it's fair to say. We then wanted to look at some displacey elements to see if there's any sort of elements of these articles, named entities, that are coming up more prominently in either article. Again, there are some slight differences. So when we examined the real articles, we found that people accounted for about 29% of the named entities compared to 25% in fake articles. So maybe slightly less likely to come up in fake articles. Where there was a huge difference was the geopolitical entities coming out in the fake articles accounted for almost 20% as opposed to almost only about 13% in the real articles as well. So quite a difference there. And again, that actually, when we break these down even further, that does become a little bit more prominent. Again, no surprise that Trump features very strongly in both, but there's a huge distinction in the fake articles that Trump is actually, funnily enough, both the top mentioned name and actually the 10th most mentioned name as well with his first article. So hopefully you can start to get a bit of a sense of what to be looking out for, what the articles might be touching on when you're examining these fake ones. We saw as well GPEs were really high in the fake, and again we've got sort of US coming up, the United States coming up in those fake articles as well, whereas the real articles have a much more, I'd say, fair spread of the type of entities that are coming up. As I say, we then wanted to look at whether sentiment analysis can actually help us establish whether the articles are real or fake. And we found again on Kaggle, a data file with over 74,000 tweets, again covering a range of topics: video games, like manufacturing companies, social media companies, and again with an array of positive, negative, as well as neutral and irrelevant feedback as well. And we then spent a lot of time, and I'd love to claim the work for this, but Claire and Stuart in our team hid themselves away and spent a long time hammering out and finally got our TensorFlow model working. It got working at about 329, so we've not had a full chance to apply it yet. Hence, our results are currently a little bit bland. We haven't quite managed to see if the sentiment is making a huge difference in determining whether it's fake or real, but that will be our next step. But I think we gave ourselves such a pat on the back for getting the model actually working after a long time of it not working that we didn't really care at this point, in all honesty.
Brilliant.
Yes.
No, sorry, I have to wait for it to play. Yeah, no, amazing. I don't think you should be too hard on yourself for not managing to get results out with 60 seconds to spare from the model working. I think that would be pretty ambitious for any of us. But yeah, amazing work getting that working. I really liked your insights that you generated, both in the word clouds and the named entity stuff about the kind of real versus fake. Some really interesting stuff coming out of there. Not just the words themselves, but I liked that you were kind of looking at some of the metadata around, well, what are the frequencies of those entity types, and actually found some really interesting stuff. Just even mentioning things like countries and geopolitical entities. There seems to be a clear difference between real and fake news. That in itself is interesting. So some really, really good work there. And I have to say, some HSMA level puns in your slides, which did not go unnoticed.
So if there's anything we wanted you to take from it, it was that. So
yes. If you want to get me on side, just write some puns.
Yeah.
That's pretty much we won over. Fantastic. No, thank you again. Great work. Okay, so last up we've got Zylog. Zylog.
Sounds like it's probably going to be me speaking, and Peter's got the slides. Thank you very much, Peter. So we were looking at this rebellions in Parliament was our aim, but our first aim was to try and get this data set down and running. And so our ultimate aim is to try and work out what makes a rebel, and can we predict them from what they're saying in Parliament, and also could we use that maybe to predict when an election is coming along. That's long term, and does sentiment change over time? So we used several different data sources. So one was Handyset, which is a labeled data source of Hansard debates, that's Parliament debates, with what the sentiment is that was coded by humans. And we also got another data set of transcripts of debates that weren't labeled. And we've also wrote a script to download updated data sets from Hansard and from They Work For You. And those data sets we'll come to in a minute. So initially, we decided we were going to train and refine our model and then look at the sentiment trend. Like everyone else with the TensorFlow issue, when we tried to train our TensorFlow models, we ran into difficulties. So we trained a simple regression model so we could use that for further analysis, whilst meanwhile some of the team disappeared off to try and get the TensorFlow running. And also, we had some word clouds made to show what people were saying. And we're looking here at speeches that were government rebels or opposition rebels, and government non-rebels and opposition non-rebels. And it's quite interesting, a lot of the rebel speeches, particularly the opposition rebel speeches, they're talking about their local place. So it looks to me like people, MPs tend to rebel when it looks like their local population is being involved. So that's quite interesting. Parochial MPs, I guess they're supposed to be, really. Now, this is a beautiful visualization that Sean went off and looked at our visualizations over time. And he's also done an interactive page for this. Do you want to demo that, Sean? Switch to Sean.
Yeah, sure.
Yeah, brilliant.
Let me. Oh, he has got it. Okay, perfect. Yeah. So we basically used Plotly, and we plotted the results for the sentiment analysis of the speeches from this data set poll vote, which basically just contains a whole list of speeches over time. And in that first visualization, that was looking at, of all of the speeches, how could we classify them as positive or negative based on sentiment? And we've tried to overlay that with when the elections were and who was voted in, which is what the dotted lines are. And then if we scroll down, we've also got the number of positive speeches by each party. So for some reason, when the coalition happened, Labour just started to have a lot of very positiveness. And then we also looked, because we have to, at the next one, which was Liz Truss's speeches that she gave. And you'll note that the time range is small. Very positive, though.
Thank you. That's excellent. So we're back to the Canva. Thank you. So the fall of Truss is a very interesting one in that she was so positive all the time. And we do have the traditional lettuce there, so you know who we're talking about. So extensions that we've done to this, so we have written a script that will extract speeches and the votes to date, because that data set went up to 2019. So we've now got the data set up till yesterday, whenever the Parliament was last sitting. We haven't run the analysis on that yet. That time beat us on that. So we've got the data, but just didn't have time to run the analysis on it. We'd quite like to make this, or I'd quite like to make this a little script that just continuously downloads and marks sentiment and displays it somehow. And the other thing that'd be quite interesting to do is to look at the concordance of sentiment between parties. So does it change over time? From the data we've seen already, you can see that after 2011, I think it was, there was a massive increase in both positive and negative speeches, and the negatives, there's a big sort of division. And so we seem to have a more divisive parliament than we've had previously, which kind of concurs with our memories. And then the final slide, please. Oh yeah, vote Zilog, must say that. I just wanted to add in what we've learned, which we didn't put in. So one of the things we learned is that data science on non-pre-prepared data is much harder than data science on data that's been carefully corralled for you. So actually getting the data and wrangling it into some form that you can manipulate it and assess it is a huge part of the task, And the other thing we learned was that dividing our tasks up into small groups and each of us going off and doing something and coming back was a hugely powerful technique for getting a lot done very quickly. So I thought the team did a brilliant job there. Thank you. That's our summary.
Brilliant. No, thank you very much. And yeah, really nice really nice insights there around that and around your sort of learning from that. And you're absolutely right. I mean, the you know, and it's kind of one of the reasons we wanted to do something like this, because you know, when you go out and do your project work, you're not going to have a nice little pre-processed data set that Dan's nicely tidied up for you, ready to hand over for your exercise for the neural networks. You will be dealing with all sorts of rubbish, and actually having to try and deal with that is such an important part of any modelling or data science project. So yeah, hugely important. So it's great that that you managed to do that. But I mean, a beautiful presentation, I have to say. Your visualization's absolutely lovely. Really love those interactive plots, and some really interesting insights coming out there, looking at the language of the rebels and how that was, you know, the positivity and negativity over time. I just thought that was really nice insights that you've drawn out there, and it sounds great that you sort of want to make that into a more sort of real-time thing. So really nice, really nicely done. Okay, so that was all 10 presentations. I'm going to suggest that, Sammy, I'm presuming you're going to need a bit of time to think about which ones are going to be deserving of these points. Would that be fair to say? Yes.
Definitely. I have a huge amount of notes to go through. Cracking work, everyone. And even those of you who said, oh, we didn't get much done, you know, you achieved an awful lot. You know, you've learned an awful lot, and yeah, just fantastic work.
So what I can do. So no, I totally agree with that. I've been scribbling down so many notes. I've flagged up ones that I think have been jumping out in particular, but Sammy and I need to confer and have a chat about this to do your all of your amazing work justice. However, we do have a people's vote, so I'm just going to close off. If you haven't yet submitted your people's vote scores, please do so in the next 20 seconds or so, because I'm about to close it, and then I will be able to announce. There is quite a clear winner so far, but that could change in the next 20 seconds. But remember, you'll all get points based on the allocations that, assuming somebody's voted for your group, which it appears that is the case for all groups. But yeah, there is definitely a clear winner that's come out of this. So just give you another 10 seconds just to do that. Just having a look. Interesting. Okay, yeah, interesting. I was just cross-checking who that was. Yeah. Okay. So I'm now going to close down the vote, if I can remember how I do that. Sammy, how do I do that? Settings, is it? I found the button earlier. Where's the button? Oh, hang on. I know where it is. Turn off responses. There we go. Okay. The polls have now closed. I am now going to share my screen and show you the results. Unless you can, are you able to see that? Is that coming through? You can tell I don't use Menti much. Can anybody say, are they able to see the results?
I'm afraid.
Sorry?
Nothing sharing on this screen on Zoom.
Fine. I just wanted to check that you hadn't already seen it. Okay, so let me share my screen. Here we are. Here are the final results. Massive congratulations to ARM with a storming victory there. Really well done. So 23% of the vote. So whatever else happens from the votes of the from myself and Sammy, the panel, you will be getting 23 points coming your way. Also, honourable mentions there to TIA and Zilog as well. For those fantastic projects, and I have to say, lots of agreement around most of the group. So everyone getting lots of praise there, because I have to say, Sammy and I have a very difficult task choosing between those presentations. They were all of an exceptionally high standard. You all did absolutely amazing things in 3 hours. That I still cannot quite comprehend, and came out with some amazing stuff. And I'm so looking forward to you doing your project work in phase 2, where you'll have 9 months in order to do stuff that's going to make a real difference for people's lives. And, you know, based on today's work and what you've done in 3 hours, I think you're all going to go on to do some absolutely amazing stuff there. So I'll stop sharing there. Well done to everyone for that. We will get back to you. There are nearly 300 points that Sammy and I are going to be allocating, so the leaderboard is going to change quite significantly, and we will update you as soon as we've got the scores. But thank you for everyone for coming along today. Thank you as well to Mike and Anna for coming along from the wider Pencore team. I hope you've enjoyed the presentations that you've seen today. But really well done, everyone. Absolutely amazing work. Again, I go back to what I said this morning. Just 4 months ago, effectively 16 days in HSMA time, you were learning how to print the words "Hello World" to the screen and how to add two numbers together. Now look at what you've done today and the sort of stuff that you managed to achieve. Absolutely incredible. So really well done, everyone. Can't wait to see more. Just a reminder, there is no session for the next 2 weeks. We are on the HSMA summer break, which is a fancy way of saying I'm on leave. So the next session will be in 3 weeks' time. I will post out information about that tomorrow. We are looking... Oh, it's system dynamics. Hooray! Hooray. I don't like system dynamics, but I'm going to teach it to you and I will try and make it fun. It's very simple, so that's good. We're going to look at system dynamics, and then we're going to go into agent-based simulation via the way of cellular automata as we get into behavioral modeling and a whole different style of modeling. Sammy, anything you wanted to add before we... Oh, sorry, project drop-in. Somebody's just reminded me in the chat. Yes, there is another project development clinic tomorrow, 10 to 11. If you've got an idea for a project, you want to come along and talk to us, even if it's a nugget of an idea, come along and we will do our best to try and give you some advice. Anything to add? Sorry, Sammy.
No, yeah, that was one of them, and the other thing is, so if you look at your calendars, there was a revision session for this module scheduled for Thursday. We're going to can that for now, just while we continue to work out the best way to provide these revision sessions. One of the options that's being floated is a hackathon, an optional hackathon for the machine learning module instead after this, and actually just having you post any questions or book in one-to-ones with me if you've got any specific natural language queries, although I can't say that natural language processing is my forte, so I may not be able to be a huge amount of help on that front. If you do have any wider course queries, if you're still having any difficulties with your IT, etc., I do still have some open slots every week for one-to-one discussions, so please do. I will share the link again after this. It's just a booking form. You can book in for a half-hour slot with me a couple of times a week. I'm very happy to still chat through any ongoing queries you're having about the course more generally or IT issues. So please do make use of those.
Yeah, brilliant. Thank you, Sammy. And yeah, no, totally agree. Make use of the stuff that's available. And obviously, hopefully, you're all starting to think in earnest about your projects now. Just to flag up, the next module, module 6, probably the last module when we cover system dynamics and agent-based simulation. Probably the last module that covers content that you would want to frame a project around. Module 7. And module 8, where we go through things like Git and web applications and some of the modern analytics stuff and forecasting that Sammy will cover, is stuff that you'll probably enhance and add into your projects, but most of the stuff that you'll be framing your projects around will be covered by the end of module 6. So hopefully you're all having those ideas, talking, make sure you're talking to people in your organizations about potential ideas for projects, because the October is swiftly approaching. And soon it'll be over to you. It'll be also great, just a final thing to say, great to hear some feedback about how you found today. As I mentioned before, we are thinking about using these hackathons for a future round of the programme as the kind of building them into each module, at the end of each module as part of the core training, to give you a chance to practice these kind of important skills. So if you did find that useful, if you didn't find that useful, please do let us know, and that'll help us determine. It's the first time we've ever done a hackathon. I certainly enjoyed it, apart from those 2 hours I was trying to debug Keras, which was not fun. But the rest of it, and certainly viewing your presentations at the end of the day, absolutely amazing. So I'm absolutely chuffed that you've managed to do so much today. Brilliant. Okay, I promise I will now stop talking before someone comes on with a cane and pulls me off the stage. So goodbye. See you in 2 weeks. Have a great summer break if you're also on break, and see you in September.